Introduction. A factor is a number which divides the other number exactly. It is also called the divisor of the given number. A factor of a number divides the number equally. For example, the factors for the natural number 20 are 1, 2, 4, 5, 10 and 20. The factors of the prime numbers are 1 and the number itself. For example, the number 11 can be written in two ways as given below, which implies for any prime number, the factors are 1 and the number itself. Factors for the given number can be found out using factor tree method also. Here is an example to find the factors of the natural number 60 using factor tree method. Similarly, we can also express algebraic expressions as product of their factors. In this chapter, we are going to discuss how to find the factors of an algebraic expression. Objectives. At the end of this lesson, you'll be able to compute the factor of an algebraic expression, find the factors using method of common factors, determine the factors by the method of regrouping, deduce the factors of an algebraic expression using the identities, evaluate division of a polynomial by another polynomial, identify errors while evaluating an algebraic expression. Factorization. Each term in an expression is formed by the product of factors. For example, in the expression 2xy plus 7x, the term 2xy has been formed by the factors 2x and y. 2xy is equal to 2 into x into y. 2x and y are prime factors of 2xy. In algebraic expressions, we use irreducible. Instead of prime, we say that 2 into x into y is the irreducible form of 2xy. Consider the expression 5x into x plus 2 into x plus 7. It can be expressed in its irreducible factor form as the process of writing the algebraic expression as the product of two or more algebraic expressions are called factorization. Expression like 2xy, 5x square, y square, 3x into x plus 7, 7 into z plus 1 into z plus 2 are already in factor form. Consider the expressions 2x square plus 4x, 3x plus 9y, x square plus 6x plus 8. To find the factors for the above expressions, we need to follow systematic methods. Method of common factors. Factorize 3x plus 9. We shall write each term as a product of irreducible factors. 3x is equal to 3 into x. 9 is equal to 3 into 3. 3x plus 9 is equal to 3 into x plus 3 into 3. 3 is the common factor for both the terms. By distributive law, 3 into x plus 3 is equal to 3 into x plus 3 into 3. Thus, 3x plus 9 is equal to 3 into x plus 3, which equals 3 into x plus 3. The factors are 3 and x plus 3. These factors are irreducible. Factorization by regrouping terms. The terms in an expression are grouped in such a way that we can find a common factor in each group. When we do in this manner, we can find a common factor between the groups which leads to the factorization of the given expression. This method of finding the factors for the given expression is called regrouping. Consider the expression 5xy plus 5y plus 7x plus 7. Note that first two terms has common factors as 5 and y. Last two terms have common factor 7, but there is no single factor common to all the terms. 5xy plus 5y is equal to 5 into x into y plus 5 into y is equal to 5y into x plus 5y into 1 is equal to 5y into x plus 1. 7x plus 7 is equal to 7 into x plus 7 into 1 is equal to 7 into x plus 1. The expression 5xy plus 5y plus 7x plus 7 is now in the form of product of factors. Its factors are 5y plus 7 and x plus 1. These factors are irreducible. The same expression is considered, but we are going to group the terms in the other way. Suppose we regroup as 5xy plus 7x plus 5y plus 7 is equal to x into 5y plus 7 plus 1 into 5y plus 7 is equal to x plus 1 into 5y plus 7. Here we find that the factors are the same but in different order. In an expression, if we cannot find a common factor between the terms, then we can use the method of regrouping. Factorization using identities. The standard identities are 1. A plus b whole square is equal to a square plus b square plus 2ab. 2. A minus b whole square is equal to a square minus 2ab plus b square. 3. A plus b into a minus b is equal to a square minus b square. Using these identities, we will do the following examples. Example: factorize x square plus 18x plus 81. Solution: from the above expression, it has 3 terms and the terms are positive. Using identity 1, a is equal to x, b is equal to 9, we have a square plus 2ab plus b square is equal to x square plus 2 into x into 9 plus 9 square. X square plus 18x plus 81 is equal to x plus 9 square. Example: factorize 49x square minus 42xy plus 9y square. Solution: the above expression has 3 terms and the middle term is negative. Here a is equal to 7x, b is equal to 3y. By identity 2, 49x square minus 42xy plus 9y square is equal to 7x square minus 2 into 7x into 3y plus 3y square. 49x square minus 42xy plus 9y square is equal to 7x minus 3y square. Example: factorize 4p square minus 625. Solution: there are 2 terms, both are squares, and the second term is negative. The expression is of the form a square minus b square. By identity 3, 4p square minus 625 is equal to 2p square minus 25 square is equal to 2p plus 25 into 2p minus 25. Division of algebraic expressions. We know that 9 into 6 is equal to 54, gives 54 divided by 6 as 9, or 54 divided by 9 as 6. Similarly, we follow the division of algebraic expressions. For example, 2x into 5x raised to the power 2 is equal to 10x cubed. Therefore, 10x cubed divided by 2x is equal to 5x square, or 10x cubed divided by 5x square is equal to 2x. 3x into x plus 4 is equal to 3x square plus 12x. Therefore, 3x square plus 12x divided by 3x is equal to x plus 4, or 3x square plus 12x divided by x plus 4 is equal to 3x. Division of a polynomial by a monomial. There are two ways to divide a polynomial by a monomial. The first method by removing the common factor in the numerator and then dividing by the given monomial. Another method is by dividing each term in the numerator by the given monomial. For example, consider the division of the trinomial 8t cubed plus 9t square plus 10t by the monomial 2t. First method, 8t cubed 9t square plus 10t is equal to 2 into 2 into 2 into t into t into t plus 3 into 3 into t into t plus 5 into 2 into t. Here 2 into t is common in each term. Separating from each term we get 8t cubed plus 9t square plus 10t is equal to 2 into t into 2 into 2 into t into t plus 2 into t into 9 upon 2 into t plus 2 into t into 5, which is equal to 2t into 4t square plus 2t into 9 upon 2 into t plus 2t into 5 is equal to 2t into 4t square plus 9 upon 2 into t plus 5. Therefore, 8t cubed plus 9t square plus 10t upon 2t is equal to 2t into 4t square plus 9 upon 2 into t plus 5 whole upon 2 into t is equal to 4t square plus 9 upon 2 into t plus 5. Second method. We can also divide each term of the trinomial by the monomial using cancellation method. 8t cubed plus 9t square plus 10t divided by 2t is equal to 8t cubed minus 2t plus 9t square upon 2t plus 10t upon 2t is equal to 4r square plus 9 upon 2t plus 5. Example. Divide 48 into a square bc plus ab square c plus abc square by 6abc using both the method. Solution. First method. By taking out the common factor, 48 into a square bc plus ab square c plus abc square is equal to 2 into 2 into 2 into 2 into 3 into a into b into c plus a into b into b into c plus a into b into c into c is equal to 2 into 2 into 2 into 2 into 3 into a into b into c into a plus b plus c is equal to 16 into 3 into abc into a plus b plus c. Therefore, 48 into a square bc plus ab square c plus abc square divided by 6abc is equal to 16 into 3 into abc into a plus b plus c upon 3 into 2 into abc is equal to 8 into a plus b plus c. Second method. Using cancellation method. 48 into a square bc plus ab square c plus abc square divided by 6abc is equal to 48a square bc upon 6abc plus 48ab square c upon 6abc plus 48abc square upon 6abc is equal to 8a plus 8b plus 8c is equal to 8 into a plus b plus c. Division of polynomial by another polynomial. While dividing a polynomial by another polynomial, the dividend should be written as the factor of the divisor. Example: 9x square plus 18x divided by x plus 2. 9x square plus 18x is equal to 3 into 3 into x plus 2 into 3 into 3 into x is equal to 3 into 3 into x into x plus 2 is equal to 9x into x plus 2. 9x square plus 18x divided by x plus 2 is equal to 9x square plus 18x upon x plus 2 is equal to 9x into x plus 2 upon x plus 2 is equal to 9x. Therefore, 9x square plus 18x divided by x plus 2 is equal to 9x. Summary. Let us summarize what we have learned. Each expression can be written as the product of factors. These factors may be numbers, algebraic variables, or algebraic expressions. An irreducible factor is a factor which cannot be expressed further as a product of factors. The process of writing an algebraic expression as the product of two or more algebraic expressions is called factorization. The following steps are used in the method of common factors. Each term of the expression is written as a product of irreducible factors. Separate the common factors, and by distributive law we can combine the remaining factors. Some of the expressions are of the form a square plus 2ab plus b square, a square minus 2ab plus b square, a square minus b square, and these expressions can be easily factorized using identities. In case of division of polynomial by a polynomial, we factorize both the polynomials and cancel their common factors.